βλέπετε πίσω μου είναι ένα data center που έρχεται από το μέλλον και πάμε να δούμε τι ακριβώς είναι και τι ακριβώς συμβαίνει.
So this is our vision of a data center about 10 or 15 years from now, and it's a bit revolutionary, but it builds on technologies that you have today, and we're just sort of projecting out what, if you start from where you are now, what potentially could we be doing, as I said, about 15 or 20 years in the future. Well, one of the big things is we step away from the traditional servers mounted in racks and in cabinets, so we've gone with a fully disaggregated infrastructure instead. So instead of, as I said, standard servers, everything now is based on the tiles, and we've got compute, storage, fabric and memory. And then the computer systems are built up through software when you need them. So you have a pool of compute, you have a pool of storage, you have a pool of networking, and you pull the resources that you need from those pools when you actually want to build a computer system. And then once you change the physical way you actually implement that, the next thing we're showing is, well, let's change how we build a data center. Instead of, as I said, of the cabinets, we have the tiles and the walls, and then we can service them by robot. So the robot goes in, it configures the system, it can reconfigure, it can do replacing the faulty units, it can do diagnostics, and it goes in as well. And one of the things it can do is it can do resilience testing. So it pulls working units, provokes a failure, then sticks them back in again, and then we see how the system can adapt and handle to that. And the last thing we're showing is while this is how a big centralized data center would work, it's the same approach that would be used for what we call distributed clouds. So all the way down at the city level, at the building level, we could use the same approach, even down to even putting a number of these tiles in an autonomous vehicle. So that would be how the computer would work there instead of the more traditional way of building them. This looks very revolutionary, but it is actually, we start from where we are today. So some of these things like robotics and automation and even disaggregation and software-defined infrastructure are things we do today, but we've just decided to go, okay, let's not look 3 years out, let's look 15 years out and see, well, how the world could be radically different. Yeah, and we just sort of go, okay, let's think crazy here. Let's see, okay, if we start doing this and if we change the way we've always done things and we ditch a lot of the legacy stuff, how far and how different could we do things in the future? The biggest difference with this is it's far more efficient. So I mean, a traditional data center will run at maybe 15 or 20% efficiency if you're lucky. Because you can be far more flexible here and you decide, well, I built a data center that was optimized for storage, but I'm actually doing stuff that's more computationally intensive. The robot just goes in and takes the storage out and puts in compute. In a traditional data center, well, you bought a whole load of servers that are built and it has the compute and has the storage inside, and when I run out of storage space, well, I've got to buy more storage space, but I have no choice. I also have to buy compute. Now you only have to buy the storage, and they just go up as the tiles. So it allows you to be more efficient in terms of how you purchase. It allows you to be more efficient in terms of how you configure, and that drives up your utilization, and your TCO goes down. But also, if we use this approach with the robot, it allows us to build far denser, so we can squeeze more computing power into a particular area. And one of the things we're talking about then is liquid cooling as well, which allows you to deal with the heat and the energy problems that you'd have from squeezing it in. So in some ways, yeah, you can do more with less, and you can be far more efficient and far more flexible, and that's the big difference with this type of approach. We're in a world where the volumes of data that are being consumed are growing exponentially, and similarly the computational needs that are out there are growing exponentially. So if we look at 5G, we look at IoT, this has to be done. So the reality is there are two types of companies, the ones that do this and transform, and then the ones that are not going to be in business. So that's the reality. So I mean, we're showing a path to the future, but it is based on what's happening today, and we already see an awful lot of our own customers building this. So yeah, any company that wants to be in business in the future, it's like moving from the horse to the petrol engine. There are not many companies left running on horses. They have to go motorized. So it's the same way in the future. Everyone will do this.
Well, Tuscany has been the homeland of inventors like Galileo and Leonardo, and now Ericsson is experimenting new important use cases for 5G in Tuscany. Ericsson has a site of Ericsson Research in Tuscany and is exploring new important applications for 5G, with the important partners of the region. For example, Piaggio, the brains behind the iconic Italian scooter Vespa, with the port of Livorno, which is the gateway for Tuscany, and with important companies in the region that, for example, explore the possibility to have robots in the vineyards. As you know, Tuscany is famous for wine, and so optimizing the wine process is extremely important. Why Tuscany and what we are exactly doing? Essentially, these important industrial partners are asking to Ericsson to understand what services could be enabled by connectivity, and especially for the next coming 5G connectivity. For example, in the port of Livorno, we are helping the port authority to evolve how the cargoes and the containers are handled in order to speed up the process of loading and unloading the containers from the vessels. For example, Livorno is a city with a port, both commercial and passenger port, but the port is completely bounded by the city, so there is no possibility to enlarge the docks. So the only way to increase the number of containers that are handled is to optimize the process. And here 5G and also the Internet of Things can help very much, because can, for example, better coordinate the trucks that arrives in the port, the cranes that pick up containers and put these containers on the trucks. This is one of the use cases that we are addressing in Livorno, for example. As I said, we have also Piaggio, which is the famous scooter producer, and they would like to connect their scooters. And the scooters will never be completely automated, so we will never see self-driving scooters. This is impossible, right? But the scooters shall have to share the road with automated vehicles, for example, with self-driving vehicles. So they would like to evolve the scooter to increase the level of safety for the two-wheeled riders, right? This is an important point. Then we have also an important company which is partner of Ericsson in the field of healthcare, because near Florence there is an important biomedical district, and this company produces very big tax scanners for tomography, okay? But the problem that they have is that these tax scanners produce very, very large files, about 2 megabytes, and they have to transfer this large file while the patient is already sleeping in the surgery room, so they cannot wait 20 minutes to transfer the file. So they have asked us to find a way to transfer this file from the surgery room to a remote location in seconds instead of in 20 minutes. So here is another place in which 5G can help very much. We are talking about Tuscany here, but I have to say that these use cases are also sensible at the national level, because we have in Italy an important project with the first Italian operator team, which is called 5G for Italy. It is an initiative similar to other in Europe, like 5G for Sweden, that Ericsson has founded by the government in Sweden. And so here we present what we are doing in these different fields in Tuscany, but the same thing is also done with other partners in the other part of Italy. The benefits that Ericsson would like to achieve in this cooperation is both for society and for industry. So we have always in mind these two important points.
So here we are demonstrating the Internet of Skills. So we are basically, with this demonstration, we're showing how a doctor could bring in his skills from a remote location to try to operate a robot that is sitting remotely to help examining a person. And in this case, when the surgeon is holding a device that can help manipulate the robot, and as the robot is touching the organs, the robot can map basically the structure of this kidney, for example, and you can also map how stiff it is. And the idea would be, for example, that if you find regions that have abnormalities, for example, if it's very hard in a kidney, it may mean that you have cancer. So we are basically, when you capture that data, you can have the doctor feeling in real time that information about how stiff the organ is.
This is a kind of big data.
Yeah, exactly. So it's a very big application for 5G. So that you need very low latency when you bring in the data from this remote location into the doctor, and you want the doctor to feel the things very, very well. You also have video that is being captured in this remote location that you would like also the doctor to see, and you need things to be synchronized and arrived from this location to there in a very, very quick way. Yeah, so we're very, very close to zero. In this case, you would need probably between 1 and 10 milliseconds for you to be fine. But the less the better.
Πίσω από όλα αυτά που είδαμε βρίσκεται ένας γιατρός και σε συγκεκριμένη περίπτωση βρίσκεται ένας Έλληνας γιατρός ο οποίος θα μας δείξει τι ακριβώς συμβαίνει. Καλημέρα Κώστα.
Καλημέρα. Εκπροσωπώ αυτή τη στιγμή το King's College London που κάνω το διδακτορικό μου. Αυτή τη στιγμή χειρίζομαι ένα ρομπότ σε ένα σύστημα τηλεχειρουργικής χρησιμοποιώντας ένα γάντι το οποίο έχει αισθητήρες με τους οποίους μπορούμε να αναγνωρίσουμε τις κινήσεις τις οποίες κάνω. Και ανάλογα την κίνηση, το ρομπότ στην άλλη πλευρά κάνει την ίδια ακριβώς. Ουσιαστικά είναι μια εφαρμογή του Internet of Skills, ώστε να μπορούμε να μεταφέρουμε σε μακρινά μέρη τις δυνατότητες όπως είναι το να μπορούμε να εξετάζουμε ασθενείς ή να επιδιορθώνουμε συσκευές και τέτοια πράγματα ακριβώς. Ναι.
Με την ιδιότητα ως γιατρός, πόσο χρήσιμο πιστεύεις ότι είναι αυτό για το μέλλον τόσο της υγείας όσο και του ίδιου του ανθρώπου?
Για να πω την αλήθεια, παριστάνω τον γιατρό. Είμαι μηχανικός στις τηλεπικοινωνίες.
Σε εισαγωγικά το γιατρός.
Αλλά ναι, πιστεύω ότι στο μέλλον θα μπορούν σε έκτακτες καταστάσεις οι γιατροί να έχουν πρόσβαση σε χώρους που τώρα δεν μπορούν. Και για παράδειγμα, πρόσφατα με το ξέσπασμα του έμπολα που έγινε στην Αφρική, πολλοί γιατροί δυστυχώς έχασαν τη ζωή τους, ενώ θα μπορούσε κάποιο ρομπότ να πάει στη θέση τους και να κάνει την εξέταση.
Και από την πραγματική σου ιδιότητα πια ως μηχανικός, πώς βλέπεις λοιπόν το μέλλον αυτό?
Πιστεύω ότι οδεύουμε σε ένα μέλλον που οι τηλεπικοινωνίες θα μπορούν να δώσουν ζωή σε εφαρμογές όπως αυτές, οι οποίες θα δώσουν μια άλλη κατεύθυνση στην κοινωνία και θα μπορούμε να δούμε πρόοδο σε τομείς που αυτή τη στιγμή το χρειάζονται πολύ.
This is a remotely controlled vehicle. The vehicle is placed in a racetrack 50 kilometers south of Barcelona, and we can drive it from this seat. The showcase is low latency and that we can have with 5G. So in order to have an interactive remotely controlled session like this, you need to really have low delay, otherwise it won't work. So the latency we are down to is less than 50 milliseconds on this. And most of that part comes from video, like camera, encoding, decoding, and most of all the screens itself. We have a beam tracking 5G system on place that actually tracks the vehicles as they go around the track, and they are sending 4K video streams, 3 of them from each car. There's actually 2 cars in there. Through the uplink using multi-user MIMO.
So this thing demonstrates, not just this robot is just an example. This thing demonstrates that 5G radio and core together in an integrated system with a distributed cloud can serve a very wide variety of network society segments. So, the web industry that has already been served with 4G, but this opens up new possibilities. So here we show a robot which is packing these boxes, and then we have these rolling things that bring the boxes back and forth. This is not really several robots, it's one big robot, all controlled from the cloud, with a single master controller. They interact with one another. And for this to happen, we need very low latency, so very high performance network. The total control loop from that robot through that mobile terminal over there, up there to the base stations and to the cloud, and we decide what to do, and then the information comes back and the robot starts moving, takes 3.5 milliseconds. So we can do that 300 times a second. So that makes it possible to move all control functions to the cloud, where it's easy to program, so that we can design a very flexible system.